You're welcome to Solo Energy Channel. Today, our main focus is on energy, entropy, and exergy concepts. So that is today's main focus. And energy, entropy, and exergy concepts come from thermodynamics, and these are applicable to all fields of science and engineering. So today lesson I intend or I'm here to provide a background for better understanding of these concepts and their differences among various classes of life support system and the study of their connection, and give a comprehensive and a critical view on the most recent study of this energy and entropy and exergy concepts. I will also cover the basic principle and general definition and practical application and implication in various fields, and I'll state their characteristics and discuss the different form of exergy that we have derived. The energy of an energy, the exergy of an energy form or a substance is a measure of its usefulness or quality, or in other words, the potential to cause change. Exergy is naturally related to the concept of quality energy. So the exergy is used in determining the quality of an energy. That is what the exergy is. So therefore, in simple terms or in simple analysis, exergy analysis has been widely applied in parallel with energy analysis in order to find the most rational use of energy. Also, a brief comparison between energy and exergy analysis has been done. There have been some comparison between energy and exergy, and this has been done in various fields of science. To make everything simple or to summarize the whole introduction, I will be talking about the usability of exergy method as a tool to promote more efficient use of available energy sources that have been derived. Some of the key words over here, that is the thermodynamics, the reference state, the energy, the entropy, the exergy, the exergetic analysis, and exergy efficiencies. Before that, I would like to give some brief history of exergy. The term exergy was used for the first time by Rantu in 1956. In 1956, and refers to the Greek word ex, which means external, and ergos, which is work. Another term describing the same is available energy, or simply availability. The term exergy also relates to ideal work, as will be explained later. So the ideal work will be explained later. And exergy laws related to those lost work. One of the challenge in thermodynamics compared to mechanics is the introduction of somewhat abstract entities. That is to that entities like the properties describing the PVT system, such as internal energy, entropy, and exergy. In addition, these are special energy functions such as the entropy, the Hamza energy, and the Gibbs, which is the free energy. They are important in thermodynamic analysis but can be different to fully compared, whilst enthalpy is important for flow process. So the exergy that we are talking about here is the theoretical limit for the work potential that can be obtained from a source or a system at a given state when interacting with a reference, that is the environment, at a certain or at a constant condition. A system is said to be in a dead state when it is in thermodynamic equilibrium with its environment unless otherwise stated, or assume the dead state to be the equation below over here. So you can see the equation over here. This is the equation. PO is equal to 1 atm and TO is, that is the 25 degrees Celsius, as you can see on the screen, being underlined with a yellow line below. A system delivers the maximum possible work as it is as it undergoes a reversible process from the specific initial state to the state of its environment. And that environment is also known as the dead state. This represents the useful work potential or exergy or availability or its availability. Exergy is the amount of work obtained when some matter is brought to state of thermodynamic equilibrium with the common component of its surrounding nature by means of reversible process involving interaction only with the above mentioned component of the nature. And since the term reversible process is used in the definition of exergy, one could simply say that the exergy of a system at a certain thermodynamic state is the maximum amount of work that can be obtained when the system moves from that particular state to a state of equilibrium with the surrounding. In the more general case, the system is more than an amount of heat, and the calculation of exergy become a bit more complicated. Consider a process steam with a temperature T1, with a temperature T1 and a pressure P1, which is having a pressure P1 with a negligible kinetic and potential energy. The traditional control volume used by Moron and Sovereign. This Moron is a book that is used or that describe the exergy that we are using today to discuss the mass, the energy, and entropy balance for open system. Is replaced an by a device used by Catos 4 to develop expression for exergy. So the device look very simple. I'm going to draw it over here. The device look like this, where we have the Q, CV, we have the QCV over here. So this area is the environment. This is the environment, and we have the Q over here, and we have the PO minus TO, and below over here is the reversible physical process. The physical reversible physical process. So here is so I represent that reversible physical process RPP rather. Then we have our WCV, and we have our pressure and temperature over here, and pressure and temperature also over here P1, and over here is supposed to be so that is how the device look like. I'm going to show the device. Don't worry about the illustration I've done over here. Don't worry about that illustration. It should be emphasized that the heat transfer to from the ideal reversible model in the figure take place at ambiguous temperature T0, and that the work produced is the maximum possible since the process in the device are reversible when the process thing is at its state or condition, which is the P1 and the T1, is brought to equilibrium with its natural surrounding, and this refers to as the environment, which is the thermodynamic state of P0 and T. And there is also an energy balance for the system, including the change of the state for the steam process through the ideal device as. And now I'm going to talk about the so as I said, I was talking about the energy and industrial ecology, the connection or the what connects energy exergy and industrial ecology is a system-oriented scientific discipline with a strong focus on environmental impact of human activities. Within industrial ecology, life cycle assessment, which is also known as the LCA, is a well-known analysis methodology trying to capture the entire lifespan of a product from its beginning to the end, from its beginning to the end. Just like the day a human being is born to the day that human being die, or the day that a mobile phone or a technology is created to the day that that technology is destroyed. So the life cycle assessment, they give the number of years, the number of months, the lifespan of a product, how long the product will last. When dealing with materials, energy, forms, and sustainability, the industrial ecology community uses Exergy as a measure of quality to answer some questions like, does the human production of one unit of an economic good by method utilize more of resources of Exergy? They ask such questions by the use of life cycle assessment and industrial ecology committee and other forms. So in mind, I'll end this video here, or I'll end the lesson here. In the next lesson, which is also going to be under this energy, entropy, and exergy, I am going to talk about exergy analysis and exergy analysis of heat exchange. Thank you for watching, and don't forget to like the video and subscribe.